All right, so we're looking at continuing the concept of pairs of angles. So we looked at yesterday two groups of angles. One group, two angles that add up to 180 degrees are what kind of angles? Supplementary are the 180, 90 are the complementary. All right, so keep those straight. Remember, there's a common example of both, and then the two angles can be separated. As long as they add up to 90, technically they're complementary. As long as they add up to 180, technically they're supplementary. However, the common example of both shows the angles as adjacent angles, one right next to the other. That's the common example. So the common example for complementary, there are adjacent complementary angles. The common example for supplementary, they are adjacent supplementary angles. And we went through, we also talked about vertical angles. And again, you have a bunch of adjacent angles there besides the ones that are across from each other and are the vertical. All right, so make sure you're reviewing, This should be a familiar topic here, a few of these today. So perpendicular lines. Perpendicular lines, and I am frozen. Perpendicular lines. And these are simply lines that intersect. Lines that intersect to form what kind of angles? Say it if you know it. Right angles. Lines that intersect to form right angles. By the way, I got a couple stray angle marks floating around on my paper. Sorry about that. I don't know where they came from, but such is life. Are they on yours? All right, so I cleaned them up for you. I didn't clean them up for me. All right, so you can see the illustration right here, and we've got two perpendicular lines. You got line AB is perpendicular to line CB. Now, what's the symbol for perpendicular? It looks like an upside down T. So on B here, in red, I'm just going to put what looks like an upside down T. That is the symbol for perpendicular. Line AB is perpendicular to line CB. If I ask you a fill-in-the-blank question, I want the word perpendicular. I don't want the symbol unless I ask you to show me the symbol. Got it? But if the answer to the question is perpendicular, don't use the symbol, write the word. Okay, let's go back to A here. So how many angles are formed when we have perpendicular lines? 4. There are 4 angles there. So all 4 angles formed are rights. How am I going to make this symbol work for me? Right angles. All 4 angles formed are right angles, right? All 4. So, you know, if we numbered them, angle 1's a right angle, angle 2 is a right angle, angle 3 is a right angle, and angle 4 is a right angle. Right? So you get 4 right angles. And again, does it matter if the thing is rotated? And the answer, of course, is no. That's going to be an ugly perpendicular line. So, woohoo! Go back, wherever you are. All right, come on back. Let's see if we can get going here. Do not catch the page again. Brother, sometimes. Nope, can't do it that way. Can't do it this way. All right, I don't think I'm going to be able to get there. All right, anyhow, hopefully you understand. I'll just draw it. If you were to take the lines and do them perpendicular this way, again, as long as you have a right angle, then you have perpendicular lines. So let's talk about that. I'm only showing one right angle. Am I guaranteed that all 4 are right angles? Am I guaranteed that all 4 are right angles? Can anybody explain how we can guarantee that if one's a right angle, all 4 are right angles? Edward?
It super straight.
Okay, that doesn't make me for sure that I proved anything. Prove your case. Kristen?
If it's the right angle, then the other ones around it are going to have to be obtuse or acute. So,
Okay, but if they're obtuse or acute, it doesn't help me to get to 4 right angles.
okay.
All right, keep thinking. Come on, can we get all 4? Can we get all 4? We learned these concepts yesterday. Christina?
Measuring with your protractor.
Nope, not with the protractor. Nia? Can you get me one more right angle?
Yes, besides the to the opposite side of it,
Okay,
different angle.
and what are those called?
Um,
So she said this one right here, right? Is that what you're talking about? Is a right angle. Yeah, what are those 2 angles called? Vertical angles, right? Remember, vertical angles are congruent. So that one has to be a right angle. Can we get one of the other 2 that are left? Oh, how soon they forget. Can we get one of the other 2 that are left? Let me ask you this. What kind of angles are those 2 right there in that circle? What kind are they? Not only are they adjacent, they're what other kind of angles? They are supplementary angles. If this angle over here is 90, what's its supplement? That one's 90. And guess what? If that one's 90, what's that one? 90. See, we get all 4. If one of them's a right angle, all 4 are right angles. And that is the case. When you have perpendicular lines, all 4 angles are indeed right angles. All right, all 4. Don't forget about supplementary angles. Don't forget about vertical angles. They are the nuts and bolts. Come on, Windows. Man, Windows is having a hard time. Wow. All right, that's it. Shade, you're going away because Windows is not having a good time here. All right, let's just fill in the next one and hopefully we get this thing to cooperate a little. All right, number 2. Oh, Windows. So number 2, you guys see this illustration. What kind of lines are they? Right, those are parallel lines. So parallel lines, P-A-R-A-L-L-E-L, parallel lines. Now usually people just finish the ending. They usually say something like this. Parallel lines are 2 lines that do not do what? Intersect. But that's not exactly true. That alone is not enough for the definition of parallel. Yeah. This thing's so big, I gotta cut it down to size. All right, I got 2 lines, right? Got a ruler line, I got a whatever thing line, and it's actually for the shade. So I had 2 lines, right? And most people say, if I ask for a definition of parallel lines, they say 2 lines that do not intersect. And I'm telling you that's not enough for the definition, because watch, are you ready? Here we go. Keep watching, nothing up my sleeve. Are you ready? Are those lines parallel?
No.
Are they?
No.
Do they intersect?
No.
See? Did you catch it? Want to instant replay?
Yes.
I mean, so what's the other needed thing for parallel lines? Lines in the same what? Nia? No, that's not quite going to work, but not a bad thought. I like your thinking. It's got to be more geometric. Got to be more geometric in your thinking. Edward?
Length.
No. Length as they both go on forever to infinity. It is lines in the same plane that do not intersect. If you look back at the example, are those 2 lines in the same plane? No. But if you put them in the same plane, the only way for them not to intersect in the same plane is if they're parallel. The only way for them not to intersect in the same plane is if they're parallel. You know, think about the plane of this wall. If this one is in the plane of the wall, the only way these two will not intersect is if they're parallel. You follow? But if they don't have to be in the same plane, they could not intersect, but not be parallel. Do you see the difference? So again, it's a technicality, but parallel lines are lines in the same plane that do not intersect. Lines in the same plane that do not intersect. You should know the symbol. It's the two vertical lines, which look parallel. And again, the lines can be angled any which way, right? They don't have to be horizontal. They could be vertical, they could be angled. There's all kinds of possibilities with parallel lines. Now, the next term we want to talk about is what's called a transversal. Transversal. A transversal, not a transam. Wouldn't be bad to have a transam. Transversal. And all a transversal is a line that intersects two or more lines. A transversal is a line that intersects two or more lines. All right, so why do we bring up the word transversal? Because we want to look at relationships when a transversal intersects two lines. So C says there are three special relationships that are formed when a transversal, and again, I'm getting you to write it again so you'll begin to remember it. When a transversal, Transversal, intersects two parallel lines. So that's the condition. Transversal intersects two parallel lines. Now, I need to focus your attention here, so let me block some of this off. Right, hang in there, just be a minute. Solid fill. Now let's go white. Okay. So here's our first illustration here. Let me go a little bit higher. Let's make this thing a little bit bigger. That'll be enough. That'll work. Okay, good enough. All right, so here's the first situation. Notice the condition. So the condition is this. We are told by the terminology that line A is parallel to line B. Now, you're probably beginning to notice that in geometry, we have a couple different ways of naming things. Angles can be named by the vertex. Angles can be named by one point on one ray, the vertex, and a point on another ray. And you saw a moment ago, I named angles with numbers. Technically, a line, how do you name it? 2 points on the line with the line symbol over top, right? But there is a shorthand there as well. And if we put the lowercase a by the line, then it's line lowercase a. It's kind of a shorthand. This symbol right here says line A is parallel to line B. That's the condition. Line A is parallel to line B. Now, the red line is the transversal. So I'm going to take my red, and from the word transversal, I'm going to draw an arrow over to the red line. The red line is the transversal, the line that's intersecting two or more lines. Now, if you'll notice, between the two parallel lines, I have four angles. And it's easier thinking of these in numbers instead of thinking in letters. Your brain will like it better. For example, when I say angle 3, can you clearly see where angle 3 is? Does everybody see that? You know what angle I'm talking about with angle 3? Anybody need me to show you with color? Everybody clear where angle 3 is? And then you got an angle 4, you got an angle 5, and you got an angle 6. All right, and notice these angles are between the two parallel lines. Well, here's what happens. I color-coded them on purpose. The red ones go together, and the green ones go together. So let's do the green ones first. Looking at angle 3 and angle 6. what does it appear to be? What appears to be the case between angle 3 and angle 6? Nia? They're the same size. And what's the technical word for that? Kristen?
They're vertical.
Not vertical. No. What do we call angles that have the same measure? That's what I'm after. Begins with a C. Amber? Not complementary. Those are two that add up to 90. Hayden? Congruent. All right, so doesn't it appear like 3 and 6 are congruent, the same size? How about 5 and 4? Do they look to be the same size? And they are. And so the blue part here is congruent. G-R-U-E-N-T. C-O-N-G-R-U-E-N-T. So 4 and 5 are congruent, and 4 and 5 are congruent, and 3 and 6 are congruent. Now, how do we name these angles? How do we name them? All right, well, look at 3 and 6 and look at the transversal. Do you see how one's on one side of the transversal and the other's on the other side of the transversal? Look at the red ones. Do you see how 4 is on one side of the transversal and 5 is on the other side of the transversal? Okay? Because of them being on opposite sides, the first word is alternate. Alternate. A-L-T-E-R-N-A-T-E. Alternate. Right? One's on one side, one's on the other. So again, when we talk about these, we're talking about the pair, either the green pair or the red pair. One's on one side of the transversal, one's on the other. That's where we get the word alternate. Now, the second word comes from where the angles are located in respect to the two parallel lines. Anybody have any idea what that second word would be? Edward? No, because again, in relationship to parallel lines. Colby?
Transversal.
Not transversal, because here's what's going to happen. Let me see. It's hard for you to figure because there's so many possibilities. But we're also going to talk about angles here and here. So we have this region. So this second word, and again, I'm trying to do it so that you'll remember it. Don't draw this in your notes. This second word has to do with this region. Where later we're going to talk about a set that has to do with this region and that region. Anybody got a clue? I'll give you a hint. That second word begins with an I. Kristen? In between is the concept, and we're going to be a little bit more official than saying in between. We're going to say interior. So these are alternate interior angles. Alternate interior angles. I'm taking all this time and explaining the words so that hopefully you're not going to get these confused. Alternate interior angles. Interior meaning they're between the two parallel lines. Again, alternate meaning one's on one side of the transversal, one's on the other side. And here's what you need to tie together. If two lines are parallel and the transversal intersects them, then the alternate interior angles are congruent. So because of this, we can say this. Take your green. We can say the measure of angle 3. Leave a space. We'll put the congruent symbol in between, but stay in green. And then do measure of angle 6. And then I'm going to take my blue and put the congruent symbol. It's the equal sign with the tilde over top is the congruent symbol. Equal sign with the tilde. You guys had the tilde in typing, right? You didn't have the tilde in typing? You don't use it a whole lot, but it's there on the keyboard. All right? The tilde is a key on the keyboard. It's that shape right there, right? It's called a tilde. It is a character on your keyboard. All right? It's not your ant. All right? That would be Matilda. All right, anyhow, it's a tilde, all right? It's the squiggly bar. So that's the symbol for congruent. Now remember, whenever you see that symbol for congruent, it means that the angle measure is the same. For example, If angle 3 is, let's say, 58 degrees, what's angle 6? 58 degrees. All right? They're congruent. And we can do the exact same thing with angle 4 and angle 5. The measure of angle 4. Oops. I am violating my own geometry. Cross out your M's. Whenever you use an M, you're talking numbers. Whenever you use a congruent, you're talking shapes. And the congruent is always used in shapes. My bad. Angle 3 is congruent to angle 6, meaning the measure of angle 3 equals the measure of angle 6. Angle 4 is congruent to angle 5, meaning the measure of angle 4 equals the measure of angle 5. Again, little technicalities in geometry. Whenever you use the M, you're talking numbers, and that's when you would use an equal sign. When you don't use the M, you're talking about the shape. Shapes are congruent, numbers are equal. Does that make sense? Yeah. Shapes are congruent, numbers are equal. So that's alternate interior. Alternate interior, alternate interior. Now, please understand, only the alternate interior angles of parallel lines are congruent. So everybody look up here. I want you to focus your attention right here. Don't draw this in your notes. What if I had a green line going like this, and I had another green line going like that, and then I had the transversal across it like that? It's not being I'm in red. I'll go 4 here and 5 again. In this illustration, is angle 4 congruent to angle 5? Why not? Because the lines are not parallel. Now, if the lines were parallel, then yes, they would be congruent. If they're not congruent, guess what? The lines are not parallel. So it goes both ways. All right. So the key there is when we say they're parallel, then you're able to say that the alternate interior angles are congruent. Now we've got another term. Notice where these angles are. So let's take a look at angle 1 and angle 8. What does it look like the relationship between 1 and 8 is? Do they look to also be what? And how about 2 and 7? Congruent. So again, we have congruent angles. So what are we going to call these? Because they're not alternate interior. Luke? Excellent. Alternate, right? One's on one side of the transversal, one's on the other. Alternate, and now they're outside, so these are alternate exterior angles. All right, so again, hopefully I'm getting you to understand the words so you don't get them confused when you have to name alternate exterior angles, alternate interior angles, etc. Christina.
When you did your drawing, and the lines would look like this, but the two green lines or the two lines, they weren't parallel, and you had the line in between it.
Mm-hmm.
So those two lines, they weren't straight.
The two lines have to be parallel for the angles to be congruent. And notice we're stating the lines are parallel. Even if they look parallel, if it's not stated, can you technically say that the angles are congruent? No. What if one angle is 39 degrees and the other one is 41? Is that congruent? No. They'll look really close, though. So the key is you've got to be told that they're parallel. Otherwise, you can't assume, unless it's a lousy question written by the book. So you never know. Snuck that one in there. All right. So alternate exterior angles are congruent. So again, I can say, I'm going to take my green. Come on, Windows. I can say angle 1 is congruent to angle 8. And I'm going to take my red and I can say angle 2 is congruent to angle 7. And what would be my reasoning? That the alternate exterior angles are congruent. The alternate exterior angles are congruent. Is that okay with everybody? Oh, and let's go back. We can show this with arc marks. So So go back to number 1 with alternate interior angles. If I use a 1 arc mark here, I'll show the other angle congruent by also using a 1 arc mark there. I'm very poetic. And we can do that with 4 and 5, but we can't use 1 arc mark. We have to use a 2 arc mark. Right? Anything else with a 2 arc mark would be congruent. Because the alternate exteriors are a whole different drawing, again, I can use 1 arc mark for one of them to show them congruent, and a double arc mark on the other to show the other congruent. Okay? Congruent angles. Well, we have some more pairs that are produced. So, on these, notice we have 4 pairs that go together. 1 and 5 goes together, it's all color-coded. 2 and 6, 3 and 7, 4 and 8. Look at each pair. Look at 1 and 5. Do they look congruent? 1 and 5?
Yes.
Look at 1 and 5. Do they look congruent? How about 2 and 6? Do they look congruent?
Yes.
How about 3 and 7? Do they look congruent?
No.
Yes. How about 4 and 5? Do they look congruent? Look, you can take your protractor out and measure them. They're going to be exactly the same. Now, you may not measure well, but I'm telling you, they are exactly the same. Guaranteed, or your money back. So, what do we call these angles? These are called corresponding angles. corresponding. Corresponding angles. So, if you have parallel lines and you have a transversal, then we can say the corresponding angles are congruent. So now I'm going to list these 4 pairs. So I have angle 1 with angle 5. Notice these are not alternate, right? Because they're on the same side as the transversal, aren't they? So 1 goes with 5, 2 goes with 6, 3 goes with 7, and 4 goes with 8. And I'll stick the congruent symbol in between every set. So we end up with 4 pairs of congruent angles. Any questions on any of that so far? Christina?
For the first one, are we going to need to know how to identify an alternate?
Yes. Yes. So alternate interior, alternate exterior, and corresponding. Now let me show you how this can come into play. Number 4 says if the measure of angle 9 equals 60, by the way, I always like to take and label my drawing. So I'm going to go by angle 9 and put 60 degrees. Find the measure of all the other angles. Are you kidding me? All right. So here's what we want you to do. If angle 9 is 60, figure out every other angle. All right? I'll give you a minute or so to do that. So how many at this point do you think you got all 8? Let me look. Okay. So listen to what I'm going to say right here. The logic in getting all 8, there's a lot of different ways you can think it through. So, for example, if 9 is 60, 12 must be 60, because 9 and 12 are what kind of angles? Vertical angles. See, I could think that way if I want. That's just one way. Now, look at this. If 12 is 60, 13 must be 60, because what are 12 and 13? Alternate interior. Okay. Now, I could think this way. If 12 is 60, 16 must be 60, because 12 and 16 are... 12 and 16 are... 12 and 16 are... They're not alternate anything. 12 and 16 are corresponding angles. Or I could have said 13 and 16 because they're vertical angles, right? Or I could have said 9 and 16 because they're alternate exterior angles. See how many different ways you can go? Okay, so I got all those, but now what do I do? Now what do I do? Which one do you want to go for next, Kristen?
10.
And 10 is how much, Kristen?
120.
Anybody concur that 10 is 120? Kristen, what logic did you use for that?
120 plus 60 is 180.
And that's the definition of what kind of angles?
Straight.
Nia? Supplementary angles, right? 9 and 10 are supplementary angles. Now again, how do you go from here? You got a lot of different ways you can go. How about if I go 10 and 15? What are 10 and 15? Alternate exterior angles, right? What if I go 15 and 11? What are 15 and 11? Corresponding angles. What if instead I went 10 and 11? Then I would say vertical angles, right? And 16, how do I want to get, well, let's do 14, how do I want to get 14? Well, if I go 11 and 14, I go alternate interior. If I go 10 and 14, I go corresponding. If I go 15 and 14, I go vertical. You see how I can get there a lot of different ways? So homework, again, this homework is for tomorrow night, though. When you do the homework, one part wants you to give the reason. Do you see how there's more than one way to get there? So as long as what you're doing is true, it's okay. They may say vertical angles, you may say alternate interior. They may say alternate interior, you might say corresponding, because you're thinking of a different pair that gets you there. Follow? Again, as long as your logic is sound, it's a lot of different ways. But notice, with one angle, we get them all. All right, so then finish the last example. Go ahead and find the measure of angle GHK. We're only asking you for one thing. The measure of angle ATD equals 38 degrees. Find the measure of angle GHK. So, on 3, give me your answer. 1, 2, 3. Okay, I heard 130 something? All right, I'm going to label my drawing ADT. That would be this angle right here, 38 degrees. Angle ADT. Now, I need to get all the way to GHK. GHK is this angle here. So there's a lot of different ways I can get there. I can say that this angle is 38 by alternate exterior angles. Therefore, the answer has to be 142 degrees because those two are supplementary angles. And again, I could go a different way. I could have gone here and here corresponding. These are still supplementary, right? These two add up to 180. These two add up to 180. These two add up to 180. These add up to 180. Add up to 180. Add up to 180, right? Any pair of supplementary angles. So how many got 142? And the rest of you understand now how to get it? Got it? Questions? Okay, so stay with me a moment here. What do we talk about today? Perpendicular lines, lines that intersect to form right angles. Proper symbol, right upside down T. Remember, you get 4 right angles as a result. Stop packing up and give me your couple minutes. Give me my seconds here. It'll just be seconds. Then what are we talking about? Parallel lines. Remember, most students want to simply say, stop moving, just listen. Most students want to say parallel lines are lines that don't intersect. To be technically correct, there are lines in the same plane that don't intersect. Take note of the symbol. Then we took a transversal, a line that intersects 2 lines, and said, hey, if the lines are parallel that it intersects, then we know the alternate interior angles are congruent, we know the alternate exterior angles are congruent, and we know that the corresponding angles are congruent. Keep straight on those names. You will see some of those questions tomorrow on tomorrow's quiz, even though you're not doing homework off of this tonight. All right? All right, we'll quit.